Good morning and happy Friday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, so today we're going to start chapter 10 and we're going to look at section 10.1. We're going to deal with something called the square root property and the process of completing the square. So back in chapter 6, we learned how to solve a second degree equation by factoring. Take, for instance, the following problem. X squared minus 9 equals 0. X squared minus 9, we factored as the difference of two squares, and we got x plus 3 times x minus 3 equals 0. Then we took each factor that contained a variable and set it equal to 0, and then solved each of these first degree equations. The first equation, subtracting 3 from both sides, we get x equals negative 3. The second equation, adding 3 to both sides, we get x equals positive 3. So x equals negative 3 and x equals positive 3. Two solutions for a second degree equation. In this section, we're going to look at a different way of solving a second degree equation. So let's go back to this x squared minus 9 equals 0. We're going to take the equation and set it up so that on one side of the equation, we have a perfect square that contains the variable. And on the right side of the equation, we just have a constant or a number. Well, in this first example, to do this, all we have to do is add 9 to both sides of the equation. So we get x squared equals 9. So on the left side of the equation, we've got a square that contains a variable, x squared. And on the right side, we've got a constant, 9. The next step is we're going to take the square root of both sides of the equation. However, recall from our previous example that there are two solutions, negative 3 and positive 3. So what we do, when we take the square root of both sides of an equation, on the side that has the number, we're going to write plus or minus like that. So basically, x equals plus or minus 3. Now, in WebAssign, they don't use that notation, so you'll still need to list them separately. X equals 3, x equals negative 3. Okay? But this notation is used in mathematics. All right, let's take a look at another example. We have w squared minus 47 equals 0. So again, I want to get a perfect square containing the variable on one side of the equation and a constant on the other. So in this case, I'm going to add 47 to both sides of the equation, and I get w squared equals 47. Now, taking the square root of both sides, including the plus or minus, I get w equals plus or minus the square root of 47. So w equals negative the square root of 47, comma, the square root of 47. I don't need the plus sign in front of the positive root. Okay, so there's the two solutions. Now, let's say we've got something like this. U squared minus 24 equals 0. So once again, we'll put the perfect square by itself on the left and the constant on the right. So we'll add 24 to both sides of the equation. U squared equals 24. We'll take the square root of both sides, including the plus or minus. So u equals plus or minus the square root of 24. However, in the last chapter, we learned how to simplify radicals. So continuing on, they will expect us to do so. So the square root of 24 is the square root of 4 times 6, which is 2 square roots of 6. So u equals plus or minus 2 square roots of 6. So u equals what? Negative 2 square roots of 6, comma, 2 square roots of 6. Those would be the two solutions. Okay, let's see here. 5x squared minus 49 equals 0. So once again, we're going to put a perfect square on one side and a constant on the other. We'll add 49 to both sides of the equation, and we get 5x squared equals 49. However, 5 isn't a square, and I want a perfect square on the left side of the equation. So I'll divide both sides by 5, giving me x squared equals 49 over 5. So now I have a perfect square on the left equals a constant on the right. Taking the square root of both sides of the equation, I get x equals plus or minus the square root of 49 over 5. However, the square root of 49 is 7, so I get plus or minus 7 over the square root of 5. But recall in the last chapter that we learned how to rationalize the denominator. So we're going to do that. We're going to multiply by the square root of 5 over the square root of 5. And x is going to be plus or minus 7 square roots of 5 over 5. So x would be negative 7 square roots of 5 over 5, comma, 7 square roots of 5 over 5. Your two solutions. Okay, now let's say we've got something like this. The quantity x minus 1 squared equals 4. Again, I have a perfect square on one side of the equation containing the variable and a constant on the other side of the equation. So I'll take the square root of both sides, including the plus or minus. So on the left, I get x minus 1. On the right, I get plus or minus 2, because the square root of 4 is 2. But I haven't solved for x completely yet. So I need to add 1 to both sides of the equation. So x equals 1 plus or minus 2. Notice I put the 1 in front, not behind the plus or minus 2. If you put it back there, you might think that that plus or minus applies to the 1 as well as the 2, and it doesn't. So putting out the 1 in front, x equals 1 plus 2, which is 3, x equals 1 minus 2, which is negative 1. So x equals negative 1, comma, and 3. Let's see here. This says, let's see what we got. Let f of x equal the quantity x plus 5 squared for what value or values of x is f of x equal to 3. So basically 3, that's a question mark there after that. 3 is going to go in the place of f of x. So I've got x plus 5 squared equals 3. Now, I moved the 3 to the right side. I could have left 3 on the left side, but I just like to have my square with a variable on the left. So now I'm going to take the square root of both sides. So I get x plus 5 equals plus or minus the square root of 3. Continuing on, I'll subtract 5 from both sides. So x equals negative 5 plus or minus the square root of 3. I can't do anything to the square root of 3. So my two answers would be negative 5 plus the square root of 3, comma, negative 5 minus the square root of 3. Okay. Now, these problems were set up so that there was a perfect square equals a constant. What if that's not the case? What if it isn't a perfect square and we have to create it? So we're going to look at some practice exercises that lead up to something a little more complicated. And basically, we're going to start out with this, x squared plus 24x. Okay, it says complete the square and factor the resulting perfect square trinomial. All right, if we have the variable squared and it has a leading coefficient of a 1, which is what we have here, followed by what we call the linear term, the first degree term, 24x. If I take that coefficient of x, the 24, and I divide it by 2, cut it in half, and then I square the results, and I put that right there, I now have created a perfect square trinomial, the factors of which would be x plus 12 times x plus 12, or x plus 12 squared. So again, what did I do? I took this coefficient, cut it in half, squared it, and added the results. Okay, let's look at another example. Let's say I've got y squared minus 18y. Again, the coefficient of y squared is a 1. That's important. The coefficient of y is negative 18. So I'm going to take negative 18, cut it in half, square it, and add the result to make a perfect square trinomial, which now factored would be y minus 9 times y minus 9, or y minus 9, the quantity squared. And let's do one more. Let's see here. Okay, I've got x squared plus 2/5 x. So I'm going to take 2/5 and divide it by 2, which is like 2/5 times 1/2, which is 1/5. Then I'm going to take that and square it, which gives me 1 squared over 5 squared, or 1 over 25. So I'm going to add 1 over 25. Okay, so the factors are going to be x plus 1/5, x plus 1/5. Note that the quantity that I put here and here is always the quantity that's there. Just like back here, the quantity that I put here and here is the quantity that's there. The quantity that I put here and here is the quantity that's there. Okay, so rather than having to sort of start over from scratch, you can just look at what the number is you squared and put it there. Okay. Now, this says use completing the square to solve each equation. Approximate each solution to the nearest hundredth. So I've got, oops, let's switch to black pen here, x squared minus 6x minus 4 equals 0. All right, there's a process that we're going to go through, and this is how it works. Okay. First of all, I want my leading coefficient, the coefficient of the variable squared term, to be a 1. Think in terms of ax squared plus bx plus c equals 0. So I want a to be a 1. In this case, it is. Later, we'll look at examples where it's not a 1, and we'll deal with it. But if a is not 1, we have to divide everybody by that first. And we'll get there eventually, okay? So that's already done. The next thing I'm going to do is I'm going to move the constant term to the other side of the equation. So I've got x squared minus 6x equals 4. And I'm going to leave a gap right there, okay? Now, I'm going to do the same thing we did a minute ago. I'm going to take the coefficient of x, divide it by 2, square it, and add it to both sides of the equation. So I've got x squared minus 6x plus 9 equals 4 plus 9, which is 13. Okay, so let's go back through again what we did. My leading coefficient's a 1, so that's good. I moved the constant term to the right side of the equation. I took the coefficient of x, negative 6, cut it in half. I got negative 3, squared it. I got a positive 9, added 9 to both sides of the equation. So what I have now, on the left side, I have a perfect square trinomial. And on the right side, I have a constant. So I've completed the square. I am at the point where the previous problems at the beginning of today already were. So now my next step is to take the square root of both sides. So I get x minus 3 equals plus or minus the square root of 13. I'm going to add 3 to both sides. So x equals 3 plus or minus the square root of 13. So x is going to be 3 plus the square root of 13, comma, 3 minus the square root of 13. Now, those are the exact solutions, but the instructions said to also get a decimal answer to the nearest hundredth. So let's go to the next page. X equals 3 plus the square root of 13. X equals 3 minus the square root of 13. And let's approximate those answers. Okay. So let's see here. 3 plus the square root of 13. I'm getting 6.60555, etc. Rounding to the hundredth place, that would be the 0. The 5 would round up. So I'm going to get what? 6.61. Then, let's see here. 3 minus the square root of 13 is going to be negative 0.60555, etc. Again, rounding here, rounding up, I get negative 0.61. So X is 6.61 comma negative 0.61. So here are the two exact solutions, and here are the two approximate solutions. I'd ask if there's any questions, but there's nobody else here but me. Okay, let's see here. Let's take a look at this problem. X squared minus 18x plus 2 equals 0. Again, use completing the square to solve each equation, approximate solutions to the nearest hundredth. My leading coefficient is a 1, so we're good to go with that. I'm going to move the constant term to the other side of the equation. I'm going to take the coefficient of x, cut it in half, square it, and add it to both sides of the equation. So now I get x squared minus 18x plus 81 equals 79. Okay. On the left side, I have x minus 9 times x minus 9, or x minus 9, the quantity squared. Okay. Taking the square root of both sides of the equation, I get x minus 9 equals plus or minus the square root of 79. Adding 9 to both sides of the equation, x equals 9 plus or minus the square root of 79. 79 is prime. It doesn't have any perfect square factors. So x is 9 plus the square root of 79, and x is 9 minus the square root of 79. And then I'm going to approximate to the nearest hundredth. So let's see, 9 plus the square root, whoops, calculator didn't turn on. Let's try that again. 9 plus the square root of 79 equals 17.888. It goes on, but rounding to the nearest hundredth, the thousandth place would round up. So I'm going to get 17.89. And then 9 minus the square root of 79, 0.1118. The 1 in the thousandth place would round down, so we're going to get 0.11. So our exact answers are here, and our approximate answers are there. Okay. Now, let's take a look at what happens when the leading coefficient, the coefficient of this variable squared term, is not a 1. So let's say we've got the following: 2x squared minus 5x plus 2 equals 0. Okay. So I need to change the leading coefficient into a 1. So I'm going to divide each term by that leading coefficient. This gives me x squared minus 5 halves x plus 1 equals 0. So now my leading coefficient is a 1. The next thing I'm going to do is move the constant term to the other side of the equation. And again, leaving a gap. The next thing I'm going to do is take the coefficient of the linear term, that is of the x term. I'm going to divide it by 2, which is like multiplying it by a half. I'm going to take that number and square it and add it to both sides of the equation. Once I've done that, on the left side, I have a perfect square, x minus 5/4 times x minus 5/4, which is x minus 5/4 the quantity squared. On the right side, I need to combine those two terms, and the greatest, let's see, the least common denominator is 16. So I'm going to multiply -1 by 16 over 16, which gives me -16/16 plus 25/16, which is going to be 9/16. Okay, before we go on, let's review. We divided everybody by a, that is the leading coefficient of the squared variable term. We moved the constant over to the right side of the equation. We took the coefficient of x, -5/2, divided it by 2, cut it in half, that is, found that quantity, squared it, remember negative times negative is positive, added it to both sides of the equation. We now have a perfect square on the left and a constant on the right. I'm going to take this and recopy it on the next page. X minus 5/4 squared equals 9/16. So I now have completed the square. I'm going to take the square root of both sides. Don't forget the plus or minus. So I get x minus 5/4 equals plus or minus the square root of 9 is 3, the square root of 16 is 4. Okay, now I'll go ahead and add 5/4 to both sides. So x equals 5/4 plus or minus 3/4. Well, let's see. 5/4 plus 3/4 is 8/4, which is 2. 5/4 minus 3/4 is 2/4, which is 1/2. So x equals 2, comma, and 1/2 would be the two solutions. Let's see here. Where did we go? There we are. All right. Let's take a look at another example. We have 5m squared plus 13m minus 6 equals 0. So my leading coefficient is a 5. I need it to be a 1. So I'm going to divide each term on both sides of the equation by the coefficient of m squared. This gives me m squared plus 13/5 m minus 6/5 equals 0. Now I'm going to move the constant term to the other side of the equation. So I'm going to add 6/5 to both sides, which gives me m squared plus 13/5 m equals 6/5. I'm going to take the coefficient of m, which is 13/5. I'm going to divide it by 2, which is like multiplying it by a half. I get 13/10. I'm going to square that quantity. 13 squared is 169. 10 squared is 100. I'm going to add that quantity to both sides of the equation. On the left side, that completes the square, and on the right side, it just adds to the constant that's already there. So now on the left side, I get m plus 13/10 times m plus 13/10, which is m plus 13/10, the quantity squared. On the right, and I just want to remind you that this number right here is going to be that number, so you don't have to start all over and try and factor it. Okay. On the right side, the common denominator is going to be 100. So I'm going to multiply 6/5 by 20 over 20. 6/5 becomes 120 over 100, which becomes, let's see, what is that? 289 over 100. 120 plus 169 is 289. I'm going to take that and copy it on the next page. M plus 13 over 10 squared equals 289 over 100. Taking the square root of both sides of the equation. Always going too fast. And we have 289 over 100. So on the left side, I get M plus 13 tenths. On the right side, plus or minus, let's see, 289, I think is a perfect square. Let's see, the square root of 289 is 17. The square root of 100 is 10, okay. So then I'm going to subtract 13 tenths from both sides. M equals negative 13 tenths plus or minus 17 tenths. So M would be negative 13 tenths plus 17 tenths, which is 4 tenths or 2/5. M is negative 13 tenths minus 17 tenths, which is negative 30 tenths or negative 3. So M equals 2/5, comma, and negative 3. Okay, let's see here. Now we're going to use completing the square to solve each equation. And then it says approximate each solution to the nearest hundredth. So they're not going to come out nicely. Okay, we've got 6x squared minus 12x plus 1 equals 0. So the first thing is to get the leading coefficient, the coefficient of the variable squared term, equal to 1. So we're going to divide each term by that coefficient. Divide by 6, divide by 6, divide by 6, divide by 6. That gives us x squared minus 2x plus 1/6 equals 0. The next step is to move the constant term. So we'll subtract 1/6 from both sides. X squared minus 2x equals negative 1/6. The next thing we do is take the coefficient of x, which is negative 2, cut it in half, which is negative 1, square it, which is positive 1, and add that to both sides of the equation. When we've done that, we've completed the square on the left side of the equation. So now I can factor it into x minus 1 times x minus 1, or x minus 1, the quantity squared. On the right side of the equation, combining both terms, my least common denominator is 6. So I've got negative 1/6, and then I'm going to multiply 1 over 1 by 6 over 6. So I get negative 1/6 plus 6/6, which is 5/6. I'm going to take that and copy it on the next page. So x minus 1 squared equals 5/6. Taking the square root of both sides, adding a plus or minus, I get x minus 1 equals plus or minus the square root of 5/6. I'm going to add 1 to both sides. X equals 1 plus or minus the square root of 5/6. Okay, now, hang on a second here. Let me find out where I was. Yes. So we're going to rationalize the denominator by multiplying this by, well, wait, let's split this up. Hang on. Let's go back here. So this is going to be x equals 1 plus the square root of 5 over the square root of 6. Okay, plus or minus, that is. Now I'm going to rationalize the denominator by multiplying the top and the bottom by the square root of 6. So I get x equals 1 plus or minus the square root of 30 over the square root of 6. So I'm going to add 1 to both sides. X equals 1 plus or minus the square root of 30 over the square root of 6. I'm going to multiply the top and the bottom by the square root of 6. So I get x equals 1 plus or minus the square root of 30 over the square root of 6. over 6. Okay. Now, what math people will do is they like to put this into a nice package of a single fraction. Okay. To do that, you'd need a common denominator. So then you'd say, well, this is over 1, and you'd multiply by 6 over 6, and you'd get x equals 6 plus or minus the square root of 30 over 6, x equals 6 plus or minus the square root of 30 all over 6. Okay. So then you'd have x is 6 plus the square root of 30 all over 6, comma, 6 minus the square root of 30 all over 6. This doesn't change the answer. It's just a different form. I believe WebAssign will accept either form. So you could have this, but again, you'd have to have them separate, the plus and the minus, or you can have this. Now, to get the decimal approximation, we can use either one of these. Let's go ahead and let's take those, put them on the next page. I get those right. And then let's go to the calculator. Now, we need to be careful. We want to divide the entire numerator, the 6 plus the square root of 30, all by 6. So we're going to have a left-hand parentheses, 6 plus the square root of 30, close it up, divided by 6. The problem is, on some calculators, specifically the TI 30X Roman numeral 2S, which is the one recommended, when you put in the square root symbol, it also gives you a left-hand parentheses. So what you'd need to do is you'd need to close up that left-hand parentheses. So the parentheses in red are a separate set from the outer parentheses in black, okay? I need the parentheses in red to say that, oh, all of 30 is inside the radicand, or it is the radicand inside of the radical, and the black set of parentheses on the outside says the entire numerator is getting divided by 6. If you don't have that outside set, you're only dividing the square root of 30 by 6, not the entire numerator. So you need to quantify that 6 plus the square root of 30. Okay, so now let's see what happens. I'm going to go parentheses 6 plus the square root of 30, close up the parentheses around the square root of 30, a second right-hand parentheses to close up the entire numerator, divided by 6, and I get 1.91287, etc., etc. It said round to the nearest hundredth, which would be there. The 2 would round down, so you'd get 1.91. Okay. The second one, parentheses 6 minus the square root of 30, close it up. And again, you're going to have that other set of parentheses. And we get, let's see, 0.08712. Rounding at the hundredth spot, the 7 would round up. So we're going to get 0.09. So those would be your two approximate answers. Let's see here. So here's your exact answers, and here's the approximate answers. Okay. Let's see here. Let's take a look at another example. It says solve each equation, approximate the solutions to the nearest hundredth when appropriate. And again, we're going to use completing the square to do it. So 5x minus 2, the quantity squared, equals 64. Well, this is already in the form where the square has been completed. So we'll take the square root of both sides of the equation, including the plus or minus. Don't forget there's two solutions. That's a typical mistake students make. They leave out the plus or minus, and basically they've just thrown away one of the two solutions. So now we're going to get 5x minus 2 equals plus or minus 8, because the square root of 64 is 8. Okay. Now I'm going to add 2 to both sides. So I've got 5x equals 2 plus or minus 8. Then I'm going to divide both sides by 5. So x equals 2 plus or minus 8 all over 5. So x equals 2 plus 8 over 5, which is 10 over 5, which is 2. X equals 2 minus 8 over 5, which is negative 6/5. So x equals 2, comma, negative 6/5. And let's see here. How about, let's do this one. 9n squared equals 99. Well, the leading coefficient of the squared term is a 9. So we'll divide everybody by 9 and we get that. I've got my perfect square. Take the square root of both sides and I get n equals plus or minus the square root of 11. So n equals negative square root of 11, n equals positive square root of 11. Let's round those to the nearest hundredth. Let's see, square root of 11 is, or square root of negative the square root of 11, excuse me, would be negative 3.316. Rounding at the hundredth of 6 would round up, so we get negative 3.32. And then, of course, the other one would be positive 3.32, since all we have is negative the square root of 11 and positive the square root of 11. Okay, so here's the exact answers, the decimal approximations. Okay, how about this one? 3/8 x squared equals 1/8 minus x. Let's see here. Wow. I need my leading coefficient to be a 1, and it's a 3/8. So I could do this in a couple of steps. I could multiply everybody by 8 and go back and divide by 3, or I could just multiply everybody by 8/3. I'm going to do that. I'm going to do it all in one step. So I'm going to multiply this by 8/3 and this by 8/3. On the left, we get x squared. On the right, 1/8 times 8/3 would be 1/3, and then minus 8/3 x. Okay, so all I've done is I've gotten my leading coefficient to be a 1. Well, next of all, I need all the terms with the variable on the left side, and in all the previous problems, they were already there. This time I need to move it over. I could move the 1/3 over, but then my next step would be to move it right back, because remember, we want the constant over on the right side. So I'm going to add 8/3 x to both sides of the equation. So I've got x squared plus 8/3 x plus 8/3 x equals 1/3. Okay, so I've got my leading coefficient of a 1. I've moved the constant term over. All right, now we don't need this anymore. My coefficient of x is 8/3. I'm going to divide it by 2, which is like multiplying it by 1/2, which is 8/6, which reduces down to 4/3. I'm going to take the 4/3 and square it, which is 16/9. And I'm going to add that to both sides. Okay, so now on the left, I should have a perfect square, x plus 4/3. Times x plus 4/3, or x plus 4/3, the quantity squared. On the right side, I need a common denominator of a 9. So I'm going to multiply 1/3 by 3/3, which gives me 3/9 plus 16/9, which would be 19/9. So now I've got my square completed on the left and a constant on the right. I'm going to rewrite that on the next page. X plus 4/3, the quantity squared, equals 19/9. Is that correct? I think so. So now we've completed the square. Okay, so we're going to take the square root of both sides. Don't forget the plus or minus. X plus 4/3 equals plus or minus the square root of 19/3. The denominator came out rational already. That gives us a break. Let's write that a little better. Still didn't make it much better. I'm going to subtract 4/3 from both sides. So x equals negative 4/3 plus or minus the square root of 19/3. Or we could say x equals negative 4 plus or minus the square root of 19/3. So writing them separately, you'd have x is negative 4 plus the square root of 19 all over 3. X equals negative 4 minus the square root of 19 all over 3. And let's see, did they ask us to write them? Yeah, they asked us to write them to nearest hundredth. So we'll come back and do this one. Parentheses, negative 4 plus the square root of 19, close up the square root of 19 with a right-hand parentheses, close up the entire thing with another right-hand parentheses, divided by 3, 0.119, and rounding to the nearest hundredth, the 9 would round up, so we're going to get 0.12. And then the second one, we're going to get negative 2.786, so the 6 would round up, negative 2.79. Okay, let's see here. I think we're just about out of time. So for the weekend, section 10.1, and I will be back this afternoon at 1:15 with an office hour, should you have any questions. And with that, we'll stop the recording and we'll see you later.